Hi students, in this session we are going to discuss about 555 timer. So this is the last topic in our first unit. In the introduction slide it has a pictorial representation of a chip and inside architecture of a 555 timer. So a 555 timer has a, actually if considering if it has a 25 transistors and 2 diodes and 15 resistors. But in the introduction diagram we are having here, no, this diagram consists of a two comparator. These are the two comparator and a flip flop, then a discharge transistor. This is a discharge transistor and a output stage. Okay, now we will see the pin diagram of 555 timer. Okay, in this class we are going to discuss about a 555 timer. This is a chip representation of it, is how the 555 timer look like this, and also the inside components available in a chip. Actually it can be used in many electronic devices such as some toys, some kitchen applications, even in a spacecraft also 555 timer take part in a role. Okay, it produces a time delays and oscillation. This is a pin diagram. It has 8 pins. See here, here mentioning 8 pins. So pin 1. So pin 1 is act as a ground and pin 2 act as a trigger. Pin 3 act as output. Pin 4 act as a reset button for a flip-flop. And pin 5 provide a control voltage to the operational amplifier. Pin 6 provide a threshold voltage to the operational amplifier. Pin 7 act as a discharge pin for a transistor, and pin 8 we are providing positive voltage here. This is a sample pin diagram of a 555 timer. Now we will see the internal architecture and its explanation. See here, this is a inside of a 555 timer. Here, see here, this part is acting as a voltage divider. That voltage divider consists of a 3 identical resistor. It has a value of 5 kilo ohm. So at this pin, it has a 2/3 of supply voltage VCC, and in this point, it has a 1/3 of supply voltage VCC. The supply voltage VCC range is between 5 voltage to 15 voltage. Then here two comparators are there. This comparator is called threshold comparator. This comparator is called a trigger comparator. It compares the two input given in the inverting and non-inverting terminal. So in the first comparator, if the pass that is non-inverting terminal input is non-inverting terminal, this input is greater than inverting terminal, it will produce the output of 1. But if this trigger comparator is just opposite to the threshold comparator. If a negative, that it means that non-inverting terminal input is greater than non-inverting terminal, it will give an output of 0. Here non-inverting is greater, here inverting is greater, just it produces a opposite output here. Next, the first comparator, this is the first comparator. The first comparator negative input is connected to the 2/3 reference VCC. This is first comparator, this is second comparator. First comparator negative input is connected with the 2/3 of reference voltage, and it also connected with the control voltage, and also it connected with the control. This is the control, also it is connected with the control voltage, but the positive terminal is connected with the threshold pin. This positive pin is connected with the threshold pin. In the second comparator, the negative pin is connected to the trigger, and the positive pin is connected to the 1/3 of supply voltage VCC. Okay, in the voltage divider network. So using these 3 pins in the threshold comparator, it using this threshold value, this value and control voltage value, it will produce the output. The output of comparator, these two comparators given as input to the flip-flop. So in the detailed working of flip-flops, we will see in the next class. Actually, forthcoming units have a detailed explanation about the flip-flop. We will study the different flip-flop. But flip-flop is working as a buffer or memory. It can able to store either 0 or 1. It is used to store 0 or 1. It is a RS flip-flop, that is set and reset flip-flop. If the reset values, if the input value is 1, 0, it will produce a output as 0, 1. That is Q bar. It will produce a output as Q bar. If it is 0, 1, it will produce 1, 0. Okay. That is connected with the output terminal. That is Q bar output is output of the flip-flop. That is Q bar. This Q bar output of the flip-flop is connected to the output stage, which drives the source or any other devices. Okay. Then the output of the flip-flop is also connected with the transistor that connect to the discharge pin to the ground. This flip-flop output is also connected. The flip-flop output is also connected with the transistor. So that connects the discharge pin to the ground. This is about the explanation of 555 timer inside a component. Actually, 555 timers are used in different modes. Actually, it is used in monostable mode, bistable mode, normally, but in our syllabus we no need to study about that. We generally study about general architecture and general pin diagram. So this timer will used as a, its operating modes are monostable, bistable and astable. But in our syllabus we are just having a introduction and working. Okay. So in this class, we studied about a 555 timer. This timer is designed by the person Hans Hammondsit in 1971. So it was used in many, it is used in many electronic devices such as toys, kitchens, even in a spacecraft also we are using that. The timer used to produce a time delay and oscillation. Thank you guys. That's all about our unit. Uh, First unit. We will meet in the next unit. Thank you guys.